Yes. So the next type of angle is reflex. Reflex angle. This is a 180 line, right? This is an angle here. If it goes beyond that, up to this point, so 180, maybe it is 250 degrees. This angle is reflex. Why? After the 180 straight line, it extends to this point. This is a reflection of here. Can you see? That's why we call it reflex. So coming from the word reflection, reflection, reflex, reflection. It's a reflection. So you go around it, right? You cross the straight line. You start seeing the reflection of the other side. That's all. Reflex angle. So this is English. Math is English and logic, like I've been saying every day. The next type of angle is angles at a point, otherwise called circle. Angles at a point. That's the name, or called complete circle. Why angles at a point? This is a point. You begin from here, you keep drawing, drawing, drawing. You come back to the same point, generating the circle for you. So angles at a point. And you know that there's even having two semicircles, 180 plus 180, producing what? 360. Or 4 quadrants. A quadrant is 90 degrees. That's 4-sided. So 90, 90, 90, 90. 4 9 is what? 36. So you get 360 degrees. So this one is equal to 360 degrees. That's a circle. Good. The next type of basic angle is vertically opposite angles. Vertically opposite angles behaves just like scissors. Something like this. Watch me carefully. The top is equal to the down, and the right is equal to what? The left. Watch. As I close, you see that the top is closing equally, just as the down, and the left and right are also opening equally. Can you see? Top equals down, left equals right. That's vertically opposite angle. So if this angle is 120, it means that angle is also what? 120. Now let me test you here. Using the principle of straight line, can you see this is a straight line? So this plus this angle must produce what? 180. Therefore, this angle must be equal to what? 60. Do you agree? Do you agree? Yes. Because I'm applying that principle here. Straight line. So straight line, straight line. This plus this must be equal to 180. So that is it. So 120, 120. Therefore, here must also be what? 60. Now, if the examiner decides to put here 40 degrees, what do you expect here to be? He had divided the 60 into 2. So here must also be what? 20. So if it is represented by a variable y plus 40 equals 60. So that's vertically opposite angles. It happens at the same point. Direct opposite. I hope you are convinced over here. That is so simple for you to tackle. So simple. Now the next thing to look at is angle properties of parallel lines. Angle properties of parallel lines. What are parallel lines in the first place? Let's say 2 or more lines are parallel at par. What does it mean? And this is the symbol for parallel line. It can be double. Make sure they are equal. That means this line is at par with that line. Parallel lines are lines that have equal distance between them at all points. They have equal distance. So if this is 2 meters, here might be 2 meters, here might be 2 meters. It's just like a ladder. It's at par. The distance is at par. So they will never meet at any point. So parallel lines are lines that have equal distance between them at all points. And for that matter, they will not meet at any point. And for that matter, they have equal gradient. We talk about gradient more into detail, right? They have equal gradient. Now they have properties to obey. They have properties of angles that we can talk about. Now, so look at this one. Angle A has a position. Whenever you have a question about parallel lines, I would advise that look at the positions of the angles given and the ones you are looking for. It simplifies the work. It makes it so easy for you to address. Now, the position. Look at the parallel line. This parallel line AB, right? This is a parallel line. This is a parallel to that. The line that crosses the parallel line is what we call the transversal line. Transversal. Transversal. It's a transversal line. Good. Now, this line is sitting on top. So A, angle A is sitting on top of the parallel line. Can you see? It's on top of this parallel line. And it's on the left side of the transversal line. Do you get it? This is the transversal line. Yes, and this is the parallel line. So angle A is sitting on top of the parallel line and it's at the left side of the transversal line. That's all. So let's look for all angles here that are on top and left. So example is angle E. Look at example angle E. Angle E, right, is on top of this parallel line CD. Line CD is on top. And it's on the left side of this transversal line. Can you see? So it's also top left. That is the angles we call corresponding angles. So angle A corresponds with angle E. And for that matter, they are equal. So if this angle is 150 degrees, we expect that angle to also be 150 degrees. I hope it is clear. Now, let's look at the other angles. Angle B is on top of a parallel line, all right, but what? It's at the right side of transversal line, so it cannot be corresponding to A and E. F is on top, but it's on the right side. Can you see? Yes, so it cannot be parallel to it. So only A and E are parallel in this case. If I draw additional lines, good, additional transversal line, watch. Let me put here K. This is K, right? This is M. Good. Now, watch the position of K. K is on top and left. Therefore, K is also corresponding with E and A. Do you agree? M is also on top and left. Therefore, it also corresponding with A and E. So these four lines, these four angles are corresponding to each other. They correspond to each other, right? So simple. So use the position to make your work so easy to do. Hello? So easy to do. Position top, left, right? Now, let's use another angle, then we conclude. Then as you solve more questions, we get the clue. Look at H. Let's consider H, angle H. What is the position of angle H? Can you help me? Help me do that. And parallel line, that's the line CD, is where? It's down. It's under it. Can you see? It's under it. It's not on top. It's under it. And where? On the right side of this transversal line. Yes, it's on the right side of this transversal line. So we identify the position. So let's identify any other angle that is also down and right. Down and right. If I go to this point, I can see down right. Can you see angle D? Angle D is also down of this parallel line and right of the transversal line. Therefore, it's also equal to H and they correspond for that matter. Now, if I come here, maybe O. So O is down right. So O will also correspond. If I put here P, P is also down right. And they also correspond. So it is the positions you use to determine the positions. So if I pick J, angle J is down left. So this assignment, look for all the down left angles and they correspond with G. Are you okay? So corresponding angles, the word correspond means agree, agreement. So if I agree with you or if I correspond with you, it means I agree with you. For that matter, we must be equal. That is the principle. So corresponding angles are equal. They have the same position and direction. Top, left, down, right, any position at all. And they are equal. Good. Now let's move to the other one. The other type of angle is alternate angles. Alternate. Alternate. Alternate means what? Opposite. Alternate angle. Opposite angles. Yes. Opposite means opposite. I hope you get a picture. It's opposite. That means direct opposite of who I am. If I'm opposite to you, that's more or less like an enemy, right? That means if I'm left, where are you? You are right. If I'm down, you are top. That's all. That's all. So let's pick A again, right? Let's pick A again and go A to demonstrate.